Thanks for tuning in at Brackeys.
Hello everyone and welcome to video number 11 in the How to Make a 2D Platformer course. In today's video we're going to be taking a look at what will happen when our player falls to the ground. Because right now it doesn't look too good. I mean, the background sprites are revealed and he just falls to infinity and all that. So that's what we're going to take care of today. And we're also going to implement some like a cool framework, some systems that we're going to be using for future functionality. So awesome video today. Also, I just quickly want to say that if you have any questions throughout this video, please go ahead and visit forum.brackeys.com, where I, among many other developers, are ready to answer your questions. It's amazing. We just hit 1,000 members and we have an average reply per thread of just about 6. So that means for every thread, there's an average of just about 6 replies. So it's a really great place to go for answers. Cool. So that intro out of the way, let's just go ahead and get started. So first off, let's clamp the camera. You can see I've created a to-do list here. And the first thing we want to do is make sure that the camera doesn't reveal all of the different stuff going on here. We just want it to stop simply. So we can do that by clamping it. And what I mean by that is we are going to select our main camera. We're going to double click on the camera 2D follow script to open it up in MonoDevelop. Then we're just going to zoom in on this a bit. And then down here, right before we apply the new position that we've created here and done all the calculations to, right before we apply that to the transform position of the actual camera, we want to do what is called clamping it. So we want to create we want to set this new position to a new vector 3, which we are then going to give a new position .x. We want the x to remain the same. No reason not to be able to move on the x-axis. Then we want to do all of the clamping here. So we're going to do that in a sec. And then we want the z to be just new position.z and just close that off. So by clamping, what I mean is we're going to use the math.clamp function. And what this does, math.clamp, is it takes in 3 values, all of them floats. The first one is the value that we want to clamp, and then a minimum and a maximum value. And it will simply make sure that the value that we put in, which is going to be our new position.y, doesn't exceed or go below the minimum and maximum value. So if the position is more than what we want it to be, it's simply going to set it to the max value that we give it. So first off, we're going to say new position.y. This is the value that we want to clamp, comma, then the minimum value. And in here we can do maybe a variable that sets it, but I'm just going to hard code it to -1 just for a second. And then the maximum, which we don't really want to put anything, any restrictions on. So let's just do math.infinity and then close it off. Remember to close off the parentheses there or it's going to throw an error. So what we can do now is we can simply scroll up here, make another public float, and simply call this maybe y pos restriction or boundary or whatever you want to do. And we can simply set this to maybe -1 to start out with. So we can simply put that down here. So y position restriction. And that's basically it. So now when we save this, head into Unity, you can see that we have a new float here that we can adjust. And when we now hit play and try to jump down, you can see that our camera simply locks in place. So that's super awesome. And it's really cool because our guy falls behind the foreground and so he almost like disappears. Cool. So next thing we're going to do, we are going to take a look at the to-do list, is creating a player script. And this player script is going to do it can host all kinds of different functionality. Today, it's just going to take care of him falling and dying, but we could do lots of stuff in the future with this. So let's make a new script of type C#, put it on the player, and let's just call this player. Now we can double click this to open it up in MonoDevelop. And let's go ahead and first off delete the 2 default functions. We are not going to be needing those right now at least. And the first thing that we want to do inside of this player script is create a player stats class. Because what we could do inside of this is make a variable, a public float called health, and default it to, let's say, 100. Then we could do all kinds of different stuff with this health. We could have functions that maybe subtracts or adds to it, or whatever you want to do, just like we normally do. But since this public class player is so diverse and can do so many things, I mean, our player is going to do all kinds of stuff maybe in the future, then having just a health value here can be confusing when it's maybe bundled in with all kinds of other different functionality. So what we're going to do instead is we're going to use a class within a class to kind of group functionality together. So let's just keep this public float health for now, and then let's make a public class inside of the player class, and let's call this player stats. So this class is going to hold everything that has to do with the player stats. So just make, again, this is a player stats class, so we can simply open and close the brackets. And inside of here is where we are then going to put our health. Just like this. Then we want to actually store an instance of this player stats class in a variable. Because right now, if we say in the start function, whoops, I just wrote some JavaScript. So let's say if we in the, for example, start function were to now, let's say, subtract the health with 10, then this would not work because we have to access the health within the player stats class. So you might think, well, then let's just write player stats.health. But this will not work either because this class that we've made here is like the definition of a class. We have to also create an instance for it. So what we do is we create a public, and now we treat the player stats class as a type. So we simply say we want to create a public player stats variable, and we're just going to call this maybe player stats with a non-capital P, just to know that this let people know that this is an instance, and we equal it to a new player stats like this. And remember the parentheses for initializing it. And then in here, we then say player stats, but with a non-capital P. So now we are taking this definition of how the class should look and creating it in a variable. We are instantiating it, creating an instance of it, of the new player stats class. And then we are changing the health value. So, but we don't want to just start out subtracting health. Instead, we want to create a damage player method that we can call whenever we want to damage the player in any way. This can be called, for example, from an enemy or from the player script itself. And it's really up to you whether or not you want to do this inside of the player stats class or out here. But just for making this a bit easier to understand, maybe I'm going to do it within the player class. So we're going to write public void. We want this to be a public method because we're going to call it from other scripts. We don't want it to be static because we still want a reference to the player. I'm getting very programmatically correct now because we are so far in the series. If there's some things you don't quite catch up on yet, that's completely fine. This class and instances of classes and all that can be really difficult for people to understand in the beginning, but just bear with me. So we're going to create a public void and we are going to call this damage player. And yes, this is a single M to those of you who've been with me from the beginning. And now we are going to simply take in an argument. We've talked about arguments before, which is going to be a float. And actually, let's make the health an integer. There's no reason for that being a float. So let's just do health as an integer. And here we'll do an int as well. So we'll do an integer. And we're going to call this damage. You could also call it amount, whatever you want to do. And inside of this, we are going to take the player stats with a non-capital P. And we're going to say dot health minus equals damage. And what we can do now is we can then check if our health player stats dot health is less than or equal to 0. And if it is, we are going to kill the player. Oops. And that's basically all we're going to do inside of the player class right now. So now we can create a game master script with a kill player method. So to do this, what we do is we head inside of Unity and we find our GM object, hit add component, new script, and create a C# script called game master. We could be killing the player from the player object itself, from the player script. But let's say we want to do stuff like respawning or maybe creating some particles or adding delays or animations, whatever we want to do, it's great to do this outside of the game object that we're destroying. So therefore, I like to have a game master class that takes care of stuff like instantiating and removing players or enemies or whatever. So let's hit create an add. Let's double click this to open it up in Mono Develop. Let's delete the two standard functions. And inside of this game master class, we simply want to start out by creating a public void. And we're going to call this kill player. And all this function is going to do for now is simply destroy the player. But we need a reference to the player that we want to destroy. So what we can do is we can put in an argument here, just like we've done so many times before. And we could give it a type of game object or a transform, calling it player here, and then simply putting in the player here. But instead, what we could pass it is the player class as a type. We simply pass it in this player type, because then we can start to change its health, or do different things in here. Now we have access to all of this stuff. So we're just going to pass it the player here, and then we're going to inside of the destroy we're going to do player.gameObject, because the destroy expects a game object to destroy. So if that didn't make too much sense, again, just ignore it. You can also put in the game object. For now, it's going to work just as fine, but with this, we are more future-proof. Now, we want to actually call this kill player, and we can do that here. So now we just want to say game master dot kill. Whoops, forgot we want this to be a public static void, because we don't want a reference to the game master every time we want to kill a player. We simply make it static so we can kill it from everywhere, and then we pass the reference to our player in here. So now it's a static. We can simply write game master dot kill player and pass it simply type in this. This is the equivalent of writing game object if that was what you wanted to pass, or transform if that was what you wanted to send over. Instead, we are just gonna send over the player. So we simply type this. Now everything is actually working just fine, and you can see that we have no errors, but nothing will actually happen because we have no method of checking whether or not we fell down. So that's the next thing we are going to do. Almost the final point is we're going to kill the player if he falls down. So to do this, we are going to make an update function inside of the player class here. So we're going to do, right before the damage player, we're going to say, no, this is just going to be a void, and we're going to call it update. And inside of the update function, all we want to check for is if, let's say, if the transform dot position dot y is less than or equal to, and then we could do maybe -20. We can try with that. Maybe let's even let's even add a variable that will store this number. So but if it's less than or equal to -20, we are simply going to damage our player, and we are going to damage him with math.infinity. So that's going to make sure to kill him. Just going to turn up the brightness on my display here. Cool. So if we fell down to this point or under, we are going to damage our player with infinity, which is then going to call the gamemaster.killPlayer, which is going to destroy the player object. This is a very complex way of doing something pretty simple, but now we can add all kinds of stuff to this. I mean, we can maybe make death animations or create certain music and a respawn timer, and all that stuff now becomes very easy to do. So now that we've set this up, let's just quickly make a variable called, let's do fall y position, or fall boundary, and we can call this or equal this to, let's do -20, and it's of course going to be of type int. And then we can simply, instead of writing -20 here, no hard coding, we can simply put in the fall boundary. So now we have access to it inside of Unity, and everything should now be working. So if we select our player, we have an error. Okay, so I'm back. I don't know what I was thinking there. Of course, math.infinity is not able to be cast into a integer. So what we're going to do instead is we're simply going to put in a very high number. It's that basic. So let's just do 999999, and we're going to make sure that our player is killed this way. And now when we go into Unity, you should see no errors. And indeed, our fall boundary appears. And what is wrong here? Our health is not appearing. And this is a trap that many new Unity users fall into. They say, I've created this class. Make sure that we've created an instance of the class, but I can't see the variables in the inspector, even though I've made sure that the health is public. And the reason why is we need to tell Unity that this is a serializable class. So to do this, right before the player stats class, we're going to create these two brackets, and inside of them write system.serializable. So this will make sure that when we save this and head into Unity, we can now see the class, and it's even collapsible, and the health, and we can just change it in here. So now when we hit play and jump down, we are going to get an error, but everything is going to work other than that. So you can see that our player was removed, but now our main camera is throwing us an error, and that's the reason why is it it no longer has a target to follow, and so we get a missing reference exception. So let's just open up the camera, 2D follow script, and in the update function, before we do anything else, we simply want to type in if target is equal to null, then return. This will make sure that this code will only get called when it has a target to follow. So now when we hit play, and that was the last thing on our list, now everything should work. We followed 7 steps, and now when we jump down, our player gets deleted and our main camera stands still. So that was it for handling what happens when we fall down. I think we're going to have to wait with respawning the player until the next video. So thanks for watching. I hope you enjoyed it and that you were able to follow along with all of this coding. But once you understand these methods of building systems inside of C#, you can suddenly do much more powerful things, and things later on when your project get more complex will get much easier. So again, thanks for watching, and I'll see you in the next video.